This is my 555 timer circuit, which uses the 555 timer in astable mode. It has R1 being a 1 kilo ohm fixed resistor, which is tied to pin 7. It then has R2 being a 100 kilo ohm fixed resistor, which is tied from pin 7 to pin 6. It is also tied to pin 2 through these hookup wires and then grounded through the 1 microfarad capacitor. Pin 3, being the output, has the red LED, which is grounded through a 220 ohm fixed resistor. This red LED is blinking at 7.16 Hz due to the configuration of these two resistors and this capacitor. This is my 555 timer unpacked. It has the same functionality as the 555 timer over here, except it is built out and is constructed without using the 555 timer. It has a comparator, a NOR gates, and an inverter. As well, instead of using a 100 kilo ohm fixed resistor for R2, I use a potentiometer. As you can see, since I replaced R2 with a potentiometer, I can control the frequency of the flashing. And so as I turn the potentiometer, the flashing rate will increase until it maximizes out, and it seems almost as if it's just constantly on, and then I can reduce it and reduce it until it's extremely slow. If I configure an Arduino like so, with pin A4 going to just before the capacitor, and pin D2 going to the output of the 555 unpacked, you were able to visualize this circuit through the serial plotter on the Arduino, and you can observe that it produces the same square wave as the 555 chip does. This is the 555 timer unpacked. Over here, we have the trigger comparator made of 4 PNP transistors and 3 NPN transistors. Down here, we have the threshold comparator made of 4 NPN transistors and 3 PNP transistors. Here is the flip-flop, or the SR latch. Over here, we have the reset pin, or reset transistor. Here we have the output driver, and this is a discharge transistor. And as you can see, the LED is oscillating in the same manner it oscillates with the other 555 timers. To use a passive piezo in the 555 circuit, you have R1 being a 1 kilo ohm fixed resistor, R2 being a 3.3 kilo ohm fixed resistor, and C1, which is tucked under here, you can't really see it, is a 0.1 microfarad capacitor. And when you plug it in, that is 2 kilohertz. This is the application of the 555, the monostable 555 LDR. It has a 4.7 kilo ohm fixed resistor going into pin 7, and then pin 7 is tied to pin 6, and pin 6 is grounded through a 470 microfarad capacitor. Down here, through pin 2, there is a LDR in parallel with a 10 kilo ohm fixed resistor from ground, and the LDR is from VCC. And so when the lights are turned out, or the LDR experiences darkness, it provides high resistance, causing the input to pin 2 being less than 1/3 of VCC, causing the LED to turn on. Once the LDR is given backlight, and the input to pin 2 is greater than 1/3 of VCC, the LED will stay on for 2,429.9 milliseconds, which is determined through the configuration of the resistor and capacitor.